we're starting 3.1, which chapter 3 is all about systems of equations, okay? And so the question becomes, what are systems of equations, and what are the different types of systems? A third question we're going to think about is, how do we solve these systems? Because all systems have a solution, and so the way we go about solving them will also be something we cover. We're going to talk about 3 methods for solving these different types. One today, and then a couple more next week. Okay, in the upcoming sections, I should say. So, first of all, we have to know what is a system. A system of equations is a set of 2 or more equations with 2 or more variables. Okay, so 2 or more equations with 2 or more variables. Something like this. Okay, and since they're equations, we would always have an equal sign on the outside too. That would be a system. Now we're concerned with linear systems. And in linear systems, all the equations are linear. Y equals mx plus b. That's what we're concerning ourselves with. Okay? Now, when we solve a system of equations, the answer is an ordered pair. And when we solve a linear system, the solution is an ordered pair. And that solution has to satisfy both equations. Okay? So when we solve them, the answer is an ordered pair. It satisfies both. However, sometimes when we solve systems, we might have different types of solutions. Okay, we can classify linear systems. We can classify linear systems. Okay? We can have consistent versus inconsistent. That's a G. And we will pick one of those words to describe our system. Okay? Consistent or inconsistent. And then we also can say independent versus dependent. Let's look at that consistent versus inconsistent first of all. Okay? A consistent system is a set of equations or inequalities that has at least one solution. An inconsistent system is one that has no solutions. Okay? So now we're looking at the number of solutions. This first description has to do with the number of solutions. Okay? Our second one has to do with the lines we're looking at. So first of all, number of solutions. The second one, we're going to start looking at the slope and the y-intercept of our linear equations to be able to start the second way, which is independent versus dependent. Okay? An independent solution has different, or independent system is a system where the lines have different slopes. So lines have different slopes. And then we also have dependent, where we have equal slope and equal y-intercept. together somehow and kind of look at some quick examples here. I want to show you this in terms of pictures. Okay? There's 3 different ways lines can interact. Here we have a red line and a blue line. These 2 lines intersect at exactly 1 point. Okay? Here we have a red line and a blue line. These 2 lines coincide. They live exactly in the same spot. Here we have a red line and a blue line, and they are parallel. 3 different situations. Intersect, coincide, means they're exactly the same, or parallel. When the 2 lines intersect, that means that we have exactly one solution and the lines have different slopes. This is a consistent, independent system. Consistent because it has one solution, independent because the equations have different slopes. Okay? Coinciding is also consistent because it has at least one solution. In fact, this has infinitely many solutions. This is consistent because it has one. This is consistent because it has infinitely many. This, however, is dependent. The slope and y-intercept are the same because the lines are the same. So this is a consistent, dependent system. Last one is parallel. Parallel has no solutions. This is inconsistent. And because it's inconsistent, that's all we say. We do not use independent or dependent. Okay? So being able to describe what you see and classify it is kind of an important piece of information. Okay? This is basic information on systems. How we classify them and what they are. I mean, what they are and how we talk about them. Now we're going to get into solving. There's 3 ways to solve, so we'll have 3 different things to talk about.